Today we're going to save more than 800 euros on a winch for our boat. What's more, today we're going to save more than 2,000 euros on an electric winch, because we're going to see how to take care of, maintain, repair, and even motorize our boat's winches to turn them into electric ones. We'll talk about one of the most useful elements, and why not say it, one of the most expensive on a sailboat.
That electric winch thing? Is it the one where you press a button and the sail goes up by itself?
Yes.
I like that. That's so me.
I may be stingy, but you're lazy. Greetings sailors, and welcome to a new episode of the Low Cost Sailor. Today we're going to talk about the winches on board our boats, one of the most important inventions that allows us to manage all the running rigging easily and without much effort. Well, not with much effort compared to the time when neither winches nor blocks existed. As we saw in the previous episode, we're going to understand how they work and why they're so valuable, how to easily keep them in good working condition, and how to repair them. Here we'll see how to extend the life of our winches and repair many of their parts, especially the most delicate ones like the plastic pieces, even when it's no longer possible to find replacement parts on the market thanks to 3D printing. But we'll go a bit further. We're going to see just how simple and affordable it can be to convert any of the winches on our boat into an electric one, using a small accessory that we can even build ourselves. You can't imagine just how much effort you'll save when the time comes to hoist the sails with this invention. Don't miss it, because besides saving money, we're also going to learn a whole lot of truly useful things.
Winch, doesn't it have a Spanish word?
Cabrestante.
Cabrestante. Well, that really sounds like it, Reverte. I'm pretty sure he'd like cabrestante a lot more than winch.
Yes, Reverte, do you prefer cabrestante rather than winch? It's just that cabrestante kind of makes me stumble a little. Cabrestante is a fairly complicated word to pronounce. We already saw in the previous episode the importance of the running rigging on board, those lines that allow us to hoist the sails, control their tension, trim them, reef them, and in general, turn the wind's push into drive for our boats in the most efficient way. To give you an idea, on a boat like mine, 32 feet, about 10 meters, hoisting the mainsail by pulling directly on the halyard can require forces of more than 45 kilos, especially in the final stretch due to the weight of the sail and friction. Although you can still do this by hand using your own body weight, of course. But when we move on to the sheet, the numbers really start to skyrocket. A 25 square meter mainsail, hard on the wind, in a good breeze, around 20 knots, can end up exerting a force of about 400 kilos on the sheet. Imagine having to hold that by hand. It's like trying to lift 5 people hanging from a rope. The pulley systems used in some main sheets allow for significant mechanical advantage. For example, a 4.1 ratio, which makes it possible for many operations to be carried out directly by hand. But on the Genoa sheets, the load is even greater. We're talking well over 500 kilos. For one person to manage that kind of force is basically impossible. Before winches were invented, people used a whole lot of pulleys, but the hassle of having all that weight hanging from the clew, well, it really just wasn't practical. That's where the winches come in. Thanks to the length of their handle and the internal gears, we can multiply our strength by 40, for example. This means that to achieve those 500 kilos of tension, you really only have to apply 12.5 kilos of force on the handle. In other words, that 40 isn't a number I just made up. It's what we usually call the winch size. Commercial model names are typically associated with a number that tends to increase as the size goes up. For example, on my boat I have a Lumar 30, 2 Barbarossa 41.2s, and a small Harken 8 that I use for the furler. Those numbers represent the power ratio. My Lumar multiplies my strength by 30, and the other one, the 41.2, multiplies it by 41, because the 0.2 indicates that it has 2 speeds. All of this, remember, is calculated using a standard 10-inch handle. With a smaller one, you would lose a bit of that power. In short, winches multiply our strength and allow us to handle sails that otherwise would be impossible to properly trim. Winches haven't always been around. Before they even existed, as we saw in the previous episode, everything relied on brute force, so the size of the sails you could actually handle was limited. The earliest references to wooden capstans show up around 480 BC, noted by Herodotus, and Archimedes is often credited with inventing the windlass, which is essentially the horizontal relative of the winches on our boats.
So, was Archimedes basically the very first low-cost sailor then? Could you really say that?
It's just that the winch is based on the lever law and Archimedes came up with that, right? Or is it the bathtub thing?
No, it was the bathtub or both.
I think he was probably holding a lever in the bathtub. For sure, between the 15th and 19th centuries, the main players were pulleys, but in order to achieve truly significant power ratios, a large number of pulleys were needed. For example, to get a 6-to-1 ratio, the line has to travel back and forth 6 times. This means that for every single meter you want to trim in the sheet, you need to pull a full 6 meters of line. On a large boat with a sheet, for instance, about 20 meters long, you'd have roughly 120 meters of line getting in the way all around the deck. When winches first appeared, they essentially became genuine space savers. Although large capstans operated by multiple people were already in use, the modern sailing winch first emerged right at the very beginning of the 20th century. In 1903, during the America's Cup, the Reliance was the first to install modern winches beneath its deck. But the most important change arrived in 1930, with pioneers such as Ted Kenyon, who developed the essential specialized patents for modern winches. In the late 1950s, Henry Zepper from the company Lumar developed the top-action winches, which became the starting point for the ones we have today, with the handle positioned on the top. The evolution continued with the addition of 2 speeds, depending on which way you turn the handle, and in the 1970s, the creation of self-tailing winches, self-tailing, which lock the line for you and let you free up the hand you used to use to keep tension. Today there are electric, hydraulic, and even reversible winches that can trim in and ease out just by pressing a button one way or the other, but let's be honest, most ordinary folks at the prices winches go for are still stuck in the 1950s, if we're lucky, the 1970s. How a winch works is really simple and, at the same time, truly brilliant. Everything is based on a drum that is designed to rotate only in the clockwise direction and has a slightly roughened surface that helps to create friction with the lines. This alone already provides a very interesting function, holding the line securely by friction. When you take a few turns around the drum, the friction is so great that with just a couple of turns you're able to hold hundreds of kilos with the strength of only a couple of fingers. The side where the pressure from the sails is called the standing part of the line, and the side you handle, the tail end. When you want to trim, to pull in the line, the friction is still there. If the drum remained fixed in place, it would be impossible to haul in the line. But, as I've already told you, the drum is designed to rotate freely in a clockwise direction. So as soon as you pull on the tail end, the entire drum rotates along with it. The fact that it rotates in only one direction is due to the pawls, small, spring-loaded tabs that move freely in one direction and lock firmly in the other. They're responsible for the familiar click, 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 click that you hear when you turn a winch, and they're also one of its most delicate parts. If you add a handle to this very simple winch, then by the law of the lever, your force is multiplied. The relationship between the length of the handle and the radius of the drum is what determines that power. That's how the simplest ones work, like the one I have, for example, on the furler. But we really can't make the handle a whole lot longer without making it awkward and uncomfortable to use, and we can't make the drum much smaller either, because the line wouldn't have enough room to grip and it would slip. If we want to multiply this power, gears start to come into play. Basically, a small gear driving a larger one gives us additional force. The handle shaft in these geared ones isn't fixed directly to the drum, but instead to a pinion gear that drives other gears that ultimately push against the teeth of the drum itself. The more advanced models also have a second speed. The system is based on pawls that let some gears slip in one direction and then engage in the opposite direction, providing more reduction and more force. It's much like a car's gearbox. For all of this to work properly, you always have to keep steady tension on the tail so the line won't slip. But in the 1970s, someone came up with the idea that they could spare you that task by creating self-tailing winches. The principle is actually quite simple. At the top, a jaw is built in, 2 V-shaped discs that grip and bite into the line. For the system to work while trimming, a fixed tab, the stripper arm, guides the line from the drum into the jaws, then back out. With self-tailing winches, you can trim using both hands or use the winch handle without worrying that the line will slacken if you let go. As you can see, it's a really brilliantly designed system. Keeping a winch in good condition basically means minimizing as much as possible the resistance in its gears and moving parts, and ensuring that the pawls move completely freely and don't get stuck. Its worst enemy is dirt. A winch that's thoroughly clean inside and out will always work well. For it to work even better, proper lubrication is key, but you have to be very careful with that last part. For maintenance, which varies depending on the model or brand, the first thing is to remove the drum. But before you start, I'm going to give you 2 golden tips. The inside is full of springs and small parts that we don't want ending up in the sea. If you do the maintenance on board, protect any paths that lead to the water. I put down a few towels in case something gets away, and above all, I work with the winch placed inside a large box in which I've made a hole in the bottom slightly larger than the base of the winch. This ensures that any part that pops out will be contained in the box and not on the bottom of the sea.
Are you saying that from experience?
I haven't lost any parts from the winch, but as for things that have fallen into the sea, if a little spring falls...
Sure, let's see where you're going to find a spring just like that.
And good luck finding it! Before removing any part, take photos with your phone of how it was. This will help you remember the exact position of each component during reassembly. And with those 2 tips, we can start taking it apart. At the top, there's usually a screw or a threaded disc that once loosened, lets you lift the drum up and out. We'll remove all of the parts very carefully, especially the pawls and their springs. We'll clean absolutely everything using a brush or a toothbrush and an appropriate solvent. The best option, which I'm sure you all have on board, is diesel fuel. In a tub and with the brush, we can get all the parts looking like new. Just by putting it back together like that, you'd already notice the difference. But if you want to reduce friction to a minimum, lubrication comes into play. For the bearings and gears, we'll use some grease. It can be a specific type, or marine lithium grease, or even Teflon grease. For the pawls and their springs, grease is absolutely forbidden in this case. It's much too sticky, and as it slowly hardens over time, it could cause them not to work properly. To lubricate them correctly, use a very light oil such as 3-in-1 oil, WD-40, or sewing machine oil. Well, or of course the specific Lumar one they sell. We put everything back together without any pieces left over. That's what the photos are for. And that's it. You've got winches that will last for several seasons. Winches also use various plastic parts in their mechanisms, from the pawl tab to the self-tailing discs and other similar parts. Since they're made of plastic, they're more exposed to wear and are more likely to break over time. Normally, there are replacement parts. Expensive, but they do exist. At least until they stop existing, because over the years, manufacturers change the models, discontinue them, and stop making replacement parts. Maybe with the intention that you replace a winch that could actually last you decades more without any problems.
What are you implying?
I'm not implying anything, but I check the undersides of my cars every day. This is where 3D printing comes in. These days, on sites like Thingiverse, there are 3D models of many spare parts that have already been discontinued. That way you can find tabs, jaw discs, and parts for older models that are no longer in stores. With a good print in materials that are resistant to UV rays, such as ASA for example, you can get parts that will last you another 15 years with no problem. You can revisit our episode on 3D printing, and if you don't feel up to it, there are online services that can print whatever you want for you. You can even contact us directly. We can help you locate the part or provide it to you already printed for a reasonable, modest price. This is how we've already helped quite a few of you bring new life to your old winches. Also, we have the ability to duplicate an existing part. That is, if the replacement part doesn't exist and nobody has made a 3D model yet, we can scan it and redesign it for you. We've done this for winches, but we've also done it for wind gear with absolutely no spare parts available, as well as for many other plastic parts on the boat. As you can see, 3D printing solves a whole ton of problems, but it can also help improve winches with genuinely useful accessories, from plugs that keep water from getting into the handle socket, to things Carlos will come up with, like a winch accessory that you can use as a cup holder.
Anything gets better with a cup holder.
For you, it would probably be the main use you'd give a winch. The cup holder thing is all well and good, but there's an upgrade that can be great for any winch, and that is definitely motorizing it. Being able to hoist the mainsail quickly and with hardly any effort is something within reach of the lucky owners of electric winches. It's not that electric winches are good for everything, but for hoisting the sail or getting someone up the mast, they save us a huge amount of work. But these devices range from expensive to extremely expensive. The most affordable ones start around $2,500, and the price can easily shoot up to well above $6,000. On top of that, they take up quite a bit of space in the ceiling of the boat's interior, which is typically where the motor is housed. For occasional use, honestly, I don't think it's worth it. There are inventions like the Winch electric handle that offer this functionality for just another $2,000. It's still prohibitively expensive. However, you can get essentially identical functionality using a suitable drill adapter and a $50 cordless electric drill. The drill adapter is typically sold in marine supply stores for around $50. As for me, since I'm a saver, I decided a while ago to make one myself using a 3D printer. I searched around for designs and found one that you could print directly. It worked, but it was extremely fragile. With a strong pull, it would snap and break. That's why I decided to create my own reinforced version. I designed a part where the 3D printed piece serves only as the outer shell, and the inside is made of stainless steel using an M6 bolt, nuts, and a spacer with plenty of thread locker applied. I'm leaving you the links and the 3D model on our website in case you want to build it yourselves. We also have it available in our online store already assembled for $17. I've used it for a long time and it works, but it's not foolproof. It can break with a sudden impact. In a way, this is actually good because it works like a fuse, so you don't end up tearing a sail or hurting your wrist, since electric winches don't have the kind of feel you get when you do it by hand. But since many drills nowadays come with a clutch, I decided to look for a 100% all-metal version that would be the final one. And on AliExpress there are some, but they still don't go below $50. And here comes the good news. We've released our own 100% stainless steel option, and you can buy it in our online store for just $21. We're cheaper than the Chinese. Also, if you bought the printed version in our store, you can upgrade to the metal one by paying only the difference.
Isn't it already enough that Red Marines, B&G, Garmin, basically all of those guys really can't stand you? Now the Chinese too.
The Chinese? The Chinese love me. Mr. AliExpress has my photo hanging there in a frame at the entrance to the AliExpress warehouses in China. I've come out like this and they adore me because they say our best buyer. So, as you can see, for 21 and a cordless drill, you've got an electric winch. And regarding the drill, a couple of tips. I use a 20-volt one from Lidl with 45 Newton meters of torque, and for my 32-footer it's enough, and it costs less than $50 with the battery and charger included. When you're using it, it's generally better to keep the drill in screwdriver mode. You'll get a bit less speed, but noticeably more power. And remember, if your winch is a 2-speed model, the drill needs to be reversible, so you can use both speeds. You also have the option of using right-angle drills, which look a bit more like a traditional handle. I'll leave examples of these drills both in the video description and in the post on our website, and you'll be able to find them with the same 45 Newton meters of torque and very similar prices in those links. With this, all I can really tell you is that I'm going sailing. Well, I'm going to go and record a few demonstrations of just how well our adapter works. Just remember that it's available right now in our online store, and that by purchasing it, you help us keep dedicating time, lots of time, to continuing to make these videos that you enjoy so much. As you can see, these gadgets are truly amazing. They let us generate and have a kind of power that we really wouldn't otherwise have, helping us handle much bigger sails, go faster, and make a lot less effort. They're expensive and you have to take care of them. I don't know if anyone has ever thrown a winch in the trash. I would never do that. In fact, some of my winches have come up from the bottom of the sea, and I've been able to recover them, bring them back to life, and have them working perfectly here today. It's not like technologically there's some progression beyond automation, making them, well, hydraulic and whatever else. Sure, having an electric one can be very useful, but you can see that just with a $20 adapter, you can turn any of these winches into an electric one for the main functions an electric one has. Because with an electric one, you won't be able to marry the Genoa, because you won't control the force, you won't have the touch.
Now, you know what it reminded me of with that? Oh, you don't have the feel, you don't have the sensations out of the thing about books, physical books, and the e-book. The electric winch is much better.
Also, with manual ones, your hands are where they should be. They're busy. With an electric one, they aren't. So it's easier to be fiddling over there and someone goes bam and one of your fingers gets stuck.
It's easier to fix with an electric winch with a remote control?
Well, we can do that. Another thing is that since we don't have one, we're not going to do it, but we'll leave it at that. Thank you very much for your attention, sailors. I hope you enjoyed today's episode. If so, please give us a like, subscribe to the channel, click the bell to receive notifications, and you'll find additional information and links about everything we've talked about, both in the video description and on our website, www.thelowcostsailor.com. You can drop by and take a stroll through our store. You'll find wonderful things, and I'm sure that during that stroll, you'll end up taking home a drill adapter for the winch. And you already know that this way you help us. You help us just like our sponsors help us, like Smart Sails, which is sponsoring us this year, or like all of our patrons, whose contributions make it much easier for us to be able to devote the time it takes to make these videos. See you again in just a couple of weeks in a brand new, improved, and even better video of the low-cost sailor.
I just have one final question that you didn't really explain in much detail yet. What is the motorized cup holder actually like?
The advantage of the motorized cup holder is that if you put the cup holder on a motorized winch, you get it stirred but not shaken, like James Bond.
There it is.